Good morning. Today we're going to start graphing quadratics. So a quadratic is any equation of the form ax squared plus bx plus c, where the x squared is the quadratic term, the x is the linear term, and the constant is our constant term. The graph of a quadratic looks like this U-shaped thing here. It's called a parabola. So a parabola has a couple key characteristics. The first one is this line of symmetry. So this is a dotted line that runs directly through the center of my parabola, and it is a line of symmetry because if I were to fold my graph in half along this dotted line, the left and the right would be identical. Okay, so every point on the left has a matching point on the right and vice versa. Where that line of symmetry intersects my vertex, or my parabola, is our vertex. The vertex is either the highest or the lowest point on the graph, but it also runs along that line of symmetry, so it's a center for our graph. Where the graph crosses the x-axis are our x-intercepts. They are also called the roots or the solutions to the quadratic. They also are called the zeros. So to find the line of symmetry, we use this really cool equation, x equals negative b over 2a, where a and b both come from my quadratic equation. So a is the coefficient in front of x squared, and b is the coefficient in front of x. Our vertex then, since it sits on that line of symmetry, the x value for my vertex is simply the x of my line of symmetry. To find the y of my vertex, I take that value that we had and I plug it back into the function and solve. For a quadratic, there are two different directions that it could face, and each of those different directions means that there's a different piece of information that we can learn. So the first one occurs when I have a parabola opening up like a cup. This happens when the a value on the front of my x squared term is a positive number greater than 0. On a parabola that opens up, my vertex then is the lowest point on the graph. So we say that my vertex is a minimum. If, for instance, my parabola opens down like a frown, my vertex then is the highest point on the graph, and we would say that that vertex is a maximum. Okay, so whether or not we have a minimum or a maximum depends on the direction of my parabola and how it opens. So what we're going to do is we're going to do two examples of sketching the graph of a quadratic, so it's associated parabola, from the equation. This is exactly how I want you to do it on your homework. Okay, so my first quadratic is f of x equals 3x squared. So whenever I have an equation, the first thing I need to do is I need to figure out my line of symmetry, or my axis of symmetry. I'm just going to abbreviate that with AOS because I get tired of writing it all the time. So this is x equals negative b over 2a. In this quadratic, I don't have a b term and I don't have a c term. So I could have rewritten this as 3x squared plus 0x plus 0, where a is 3, b is 0, and c is 0. That's okay, that happens. So I can just go ahead and plug it in. I get negative 0 over 2 times 3, which is 6. Well, 0 divided by 6 is still going to be 0. So that means on my graph, because that's what I do next, I go to my graph, I need to draw that line of symmetry through x equals 0, which just happens to be my y-axis right here. That happened. You still need to draw your dotted line. Once I have my line of symmetry, I can go ahead and calculate my vertex. So vertex, the x-coordinate is simply whatever my line of symmetry was. So it's 0. To find the y-coordinate, I need to take this, and I need to plug it back in for the x there. So I'm basically solving my function at 0. I go ahead and I do that. I plug in 0 for x. 0 squared is 0 times 3 is just 0. So 0, 0 is going to be the vertex of my parabola. Is this parabola opening up or down? Well, the number in front of x squared is positive 3, so I expect it's going to be opening up like a cup. So that vertex 0, 0 is the minimum value on my graph. So then how do I find the other points I need? Because I need 5 points in total to graph a quadratic. from here, we just do an XY table. I always pick values that are 1 and 2 away from my vertex on either side. Okay, so I'm going to do -2, -1. I already know what 0 is, but I'll still put it on my table. And then I just take each of these and I plug them in for x. So I already know that 0 gave me 0. That's awesome. When I plug in -2, -2 squared is a positive 4, times 3 is a positive 12. When I plug -1 in, -1 squared is 1, times 3 is 3. When I plug 1 in, 1 squared is 1, times 3 is 3. When I plug 2 in, 2 squared is 4, times 3 is 12. What do we notice about my values in the table? Well, numbers that are the same distance away from my vertex are the same number. So -1 and 1, each one step away from my vertex is 0, both gave me the same y value. -2 and 2, both 2 steps away from my vertex, gave me the same y value of positive 12. This goes right along with when I said our line of symmetry splits our graph in half, and the left side is identical to the right side. So every point on my left-hand side will have a matching point in the same place on the right-hand side, which makes it really easy because though I need 5 points to graph, I don't always have to calculate 5 points. Okay, so let's go ahead and plot these, and then we'll be finished. I like to work from left to right. So at -2, I had a positive 12. At -1, I had a positive 3. At positive 1, I had a positive 3. And at positive 2, I had a positive 12. I can go ahead, oh, that was really bad, and draw the graph through these points. Just like I promised, this point right here is 2 steps away from my line of symmetry, and its match is 2 steps on the other side. This point right here is 1 step away from my line of symmetry. 1 step on the other side gives us a point in the exact same spot. So technically, I could have just used those x values, and I still would have been able to graph my function. So we're going to go ahead and do one more. This one is going to be the function -x squared minus 4x. First thing I do is find my axis of symmetry. That's -b over 2a. My b value in this function is already -4, so the negative of that becomes a positive. My a value is -1, so 2 times a -1 is a -2, which simplifies into a -2. That then is going to be the x-coordinate of my vertex. To find the y-coordinate, I take this -2, and I'm going to plug it back in for every x in my original function. -2 squared is 4. The negative of that is a -4. -4 times a -2 is a positive 8. -4 plus 8 is 4. So my vertex is -2, 4. I can come over here now and I can put my line of symmetry down and my vertex. While I'm doing this, I want you to think about whether or not this parabola opens up or if it opens down. Hopefully by now you figured out that the number in front of my x squared is a -1, which means that that is less than 0, so my parabola is going to open down like a frown, which means my vertex is going to be a maximum point on my graphs because it's going to be the highest one. Okay, so now I just need to find 4 more points and I'm done. But I don't really need 4 more points, right? I could just find 2 and then find their matches on the other side. I like to go towards 0 because I think that's easier to plug in. So my vertex was at -2, so 1 step away from that is -1. 1 more step away from that is 0. So I'm going to go ahead and plug in -1 and 0 and see what happens. When I plug -1 in, -1 squared is 1, the negative of that is -1. -4 times a -1 is positive 4. 1 plus 4, -1 plus 4 is 3. I go ahead and I plug in 0. Well, going to 0 out because all my terms have a 0 in them or have an x in them. I can plot these 2 points and find their matches on the other side. So at -1, I was at 3. So I go to my line of symmetry, and I go 1 step on the other side and find its matching point. Do the same thing with 0, 0. Plot it. Go my 2 steps to the line of symmetry, and go my 2 steps on the other side. I now have 5 points, which I can easily graph. There is another example, maybe even 2 on here if you want to look at them. I don't think we need to go through them. So I have one more thing that I'd like to go over, and then we're done. So there are 2 of these next type of example on here. However, we're not going to do both of them. We're just going to do one because I think that's sufficient. So it says, consider this quadratic. It would like to identify whether the function has a maximum or a minimum, and then to find that max or min. So I know one way that I could do this is I could graph it and then go from there. However, that's kind of a lot of work for something that really doesn't require a graph. On a parabola, my maximum or my minimum is always going to be the vertex. And I know how to find the vertex without having to do a graph. Correct? So when we get to it, I'm not going to have to graph from part B. Let's go ahead and answer part A first, though. Is my graph going to have a maximum or a minimum? Well, this depends on whether or not my parabola opens up like a cup or down like a frown, which is dependent upon the value in front of my x squared. So here I have -4. -4 is less than 0, which means my parabola is going to open down like a frown, which also tells me that my vertex, since it's at the top of that graph, is going to be a maximum. So I know this function is going to have a maximum at that vertex. Now I just need to find the vertex. So we do that. I know the coordinates of my vertex are -b over 2a, and then my function solved at -b over 2a. So I take -b over 2a and use those values. B is 12, so -12 over 2 times the -4, which is -8. Those negatives cancel each other out, and I can reduce this by pulling out a 4. So I get that my x-coordinate is 3/2. Now I need to find my y-coordinate by taking that 3/2 and plugging it into the function for x. So I have -4 times 3/2 squared plus 12 times 3/2 plus 18. I need to square the 3/2, which gives me -4 times 9/4 plus, from here I can look and see that this 2 is going to cancel out some of the 12 that I have, and it's going to turn into a 6. So I basically just divided both by 2. And then 6 times 3 is 18. And then I have the plus 18 at the end as well. I can kind of do the same thing here. This 4 is going to cancel out that 4. So I'm just going to be left with -9 plus 18 plus 18. -9 plus 18 is +9. Plus 18 is a +27. So my maximum vertex is at 3/2, 27. But remember, we label our maximums and our minimums based off of the y value. So I would say I have a max at 27. And that's how I would write this. If you have any questions, please go ahead and let me know.